people, and welcome. In today's video, we are talking about how to write an equation for a cube root function. Now, I did take the liberty of writing out some steps for you. These are the same exact steps that we take to writing a cubic function. However, there's a slight little change in that this is a cubic. This is not a cubic. This is a cube root function. As always, if I make a mistake, I am human. Just let me know where the mistake occurs so that way we both can learn from it. All right, let's go ahead and get started. So step number 1 is identify the point of symmetry. So that's going to be your middle point. Remember that H is the opposite inside the bubble. So if you see a positive H in here, you're going to write a minus H. If you see a negative, you're going to see a positive H. And that is because H itself is not attached to the minus. So when you put in H, it kind of flips the sign. Step number 2 is look at the form they are asking the equation in. So this is the difference that we have against cubic functions. So we are going to be asked to do 2 different forms. Oh, did you guys notice that? This plus k belongs inside the bubble. So let's put that inside our yellow bubble. And my OCD is kicking in, so I'm going to get rid of this line right here. There it goes. So this plus k is attached to the cube root of x minus h. Now, one thing I do want to point out is this x minus h is inside a bubble. It is a secret bubble. So if you don't see that bubble, it is grouped together. So the x minus h are grouped together. Notice that there is a bubble here. So if you're going to be using a different method than mine, remember that the b, or the 1 over b, depending on what you're being taught, the b is always the b is always factored out. So if you don't have a b factored out, if you simply have bx, or you still simply have a number x, that means that b needs to be factored out if you're going to be using a different method for graphing or a different method for plugging it in. So choose a point on the curve that is different than the point of symmetry. So you're going to choose x or y, x and y, but for a point. You're going to substitute in for x and y into the equation and solve for a or b, depending on the equation. So if they want this one, you're going to solve for a. If they want this one, they're going to solve for b. Write out your final answer. Now these steps that I have written out, yes, there are other ways to getting the equation of the graph. However, I feel that this method, these steps, will always work. There's no guessing. There's no, let's see if I go over 1 or if I go up 1. I'll talk about that a little bit later. These will always work. It might take a little bit more algebra on your part, but you will always get the correct B and you will always get the correct A. Granted, your algebra is on point. All right, let's go ahead and do 2 examples. The first example is they want it in the form of cube root of b times x minus h plus k. Okay, so the first thing we notice is that the x minus h is in a bubble and the b is outside of that bubble. So the first thing, step number 1, is to identify the point of symmetry, which is going to be your middle point. So your middle point is this one here. Again, it's kind of like that John Travolta, like vertex kind of thing. It's the middle point of symmetry. So you're going to have that middle point. This point right here is going to be your h comma k. So it is 2 comma 1. So when we are writing out the equation, I'm just going to write out the general form and then I'm going to start plugging it in. You're always going to do the opposite of h. So if you see h is positive 2, I'm going to write a minus 2. K is outside the bubble, so if you see a positive 1, it will be a positive 1. This is where different methods come into play. So you know that inside the bubble, inside of the parent function, is your horizontal stretch or compression for b. So you also know that if it's inside of the parent function, that you're going to be doing the opposite. For example, if it's a whole number, it's going to be a compression. If it is a fraction, it's going to be a stretch. So if we are looking here, for example, notice that the parent function, if we go back to a previous video, we know that our parent function has 1, 1, 0, 0, and -1, -1 as our parent reference points. How did that change? So if you notice, you go up 1. Let me change a different color. You go up 1 over 1, 2, 3. Up 1 over 3. So that means I stretched it out 3 jumps to the right, almost to the right, right? You stretch it out that way from our point of symmetry. So that means there's a horizontal stretch. That means B has to be a fraction. So if I stretch this out 3, that means I'm going to stretch it out 3. That means for B, it has to be 1/3. Now, the reason we can do it that way for this example is because you go over 1. So if you go up 1, that means your vertical stretch or compression did not happen. So it remained the same. In the parent, it goes up 1. In this function, it goes up 1. That means we don't have an A. If you can go up 1, that means you don't have an A. That means you can only go to the left or to the right for your B. In this case, we went to the right, meaning it is an increasing function. That means B is positive, and you are stretching it 3 jumps, meaning you have a horizontal stretch, meaning B is 1/3. You can do it that way. However, let's say we don't know how to do that. That to us is super duper complicated and confusing. All right. So let's go ahead and rewrite this as y. And our task here is to solve for b. So in order to solve for b, I'm going to choose my secondary point, which is this one. Always choose a pretty point on the curve. And that pretty point is 5, 2. And so for 5, 2, 5 is x, y is 2. So I'm going to start plugging it in. And I'm just kind of solving. I'm going to subtract 1 both sides before I cube root it. Again, when you're going to be cubing both sides, please make sure that you understand that it has to be the only thing on that side. So if I cannot cube both sides here because I have this plus 1, has to be the only thing. 2 minus 1 is 1. I'm going to cube both sides. 1 cubed is still 1. Cubes cancel out, so I have 3b divided by 3, divided by 3. And once again, like I said, b is 1/3. So you're going to take that 1/3, you're going to plug it into b with your h and k, and then you have your final answer. So how would our final answer look like? I'm going to write it up top here. Our final answer is g of x is equal to cube root of 3. B is 1/3 times x minus 2 plus 1, and that is our final answer. So that is for the equation of having a horizontal stretch or compression where you have a B inside of the cube root. Now let's do an example of one that has an A, so an A outside of the cube root. Our steps are going to be exactly the same. So you're going to find your point of symmetry. You're going to find your middle point, which is this one here. And a lot of times what they're going to do is they're only going to give you 2 points. Note that the middle point is the one. Notice this curve is going to the right. Notice this curve is going down and to the left. So it's the middle one. There's another pretty point right here. All right, so that's the middle one. What is that point? That point is -2 and -5, h and k. Here's our equation, and I'm actually just going to write underneath it. So we have a -2 for h. We have a k that's -2. So this is actually a good example to show you why we do the opposite when we write out the bubble. So what we really have is x minus a -2. Well, negative and a negative make a positive. So when I'm writing my equation for the cube root, I have x plus 2. So I see a -2, but I'm writing a plus 2 because of that extra negative on the inside. Plus k. Ooh, I'm going to save it. I'm going to do a plus a -5, but we can just write -5. So I'm going to rewrite this in terms of y. So let's think about the parent function. Once again, the parent function, let me actually sketch it out for you real quick. Parent function looks something like this. We have three pretty points. We have three reference points, 0, 0, 1, and 1, and negative 1, negative 1. So what happens to those pretty points? Well, they went from, let's focus on our main point. So we went down 1, 2, 3, 4, 5. We went to the left 2. And then what happened is I went up 2 and over 1. I went up 1 over 1. So I went over 1 and over 1 in both my parent function and my transformed function in this one that we have currently. Because I went over 1 in both, that means I do not have a horizontal stretch or compression. If I went over a certain number of jumps, that means there is a horizontal stretch or compression. If you do not go over a certain number except 1, that means you do not have a horizontal stretch or compression. Notice that I went up 2. That is different than what we had in our previous example. In this example, in the first example, we went up 1, which matches our parent function. In this case, we go up 2, which doesn't match our parent function, meaning something happened. So we need to find out what that A is. Now, because we go up 2 and over 1, sometimes you can think of it almost as your slope. So it is outside the bubble, it is vertical, meaning if we have a stretch, a vertical stretch of 2, that means A would be 2. But let's say we don't see that. And sometimes this can get messy when you do have a horizontal and a vertical stretch of compression happening at the same time. It can get weird. So I definitely want to show you the original method that we were doing. So you're going to choose your secondary point. I'm going to choose my secondary point as negative 1 comma negative 3. In this point, I'm going to say x is negative 1, y is negative 3. So here's negative 3 is equal to a cube root of x is negative 1 plus 2 minus 5. Negative 3 is equal to a cube root. This is a times the cube root. I'm going to just make that obvious here. Negative 1 plus 2, that is just positive 1 minus 5. Now, before I do any cube rooting or anything like that, you have to make sure that that is the only thing there. I cannot just cube both sides right now. I have a 5 that I'm going to get rid of, which means I have a, what do I have? 5, 6, 7, 8. Ooh, that's a good save right there. Now I have this times a, which I need to get rid of, which means I have a negative 8 over a is equal to the cube root of 1. Now I can cube both sides. Now, if we do this here, and we can do, because this is multiplication, if we were to cube both sides, you would have to keep in mind that that a becomes cubic as well. So let's actually do that. Let's say if you didn't want to divide by a and you kept that a, how would that look like? Because I can foresee that happening. So if I was to cube both sides, something went wrong. What went wrong? Because I'm supposed to get a vertical stretch of 2. And if I cube 8, that is not going to get me 2. And I'm noticing, do you see how I have a plus 5 here? This should be a plus 5. This should be a positive 2. That's where I went wrong. Because again, in my head, I'm thinking it should give me 2. So again, something still went wrong because if I do cube root, not cube root, if I cube both sides, that would give me an 8. And I definitely don't have a vertical stretch of 8. So let's see what else went wrong. What else went wrong? Oh, do you guys see what I'm doing? I'm being super silly. Let's go back a little bit. Let's erase this. Let's pretend this doesn't happen or didn't happen. Let's pretend I know what I'm talking about. Okay. You guys, what is the cube root of 1? Super silly of me not to see that. And I don't know why I didn't see that. I'm so into let's solve for a that I didn't even evaluate what the cube root of 1 is. The cube root of 1 is just 1. Silly Miss Romadius. Let's not do that. Let's get rid of all of this. This is a mess. I apologize, you guys. Hopefully you saw that a lot faster than I did. All right, so let's pretend that this is what I have and actually solve it the way you're supposed to solve it. The cube root of 1 is 1. 1 times a is a. Therefore, a is 2, and that's what we should have gotten. So, okay, so how would this look like in our final answer? G of x, f of x, p of x, q of x, doesn't matter. G of x is equal to 2 times the cube root of x plus 2 minus 5. And that's it. If you can notice your slope, and I do the bunny ears for a reason. If you can notice that, you're fine to do it. Just make sure that if you have a vertical stretch or compression, you are going over 1. If you have a horizontal stretch or compression, you're going up or down, depending if you have an increasing or a decreasing function. You're going up or down 1. So if you are going up or down 1, that means you have a horizontal stretch or compression. If you're going over 1, that means you have a vertical stretch or compression. All right, beautiful people, that wraps up this video. Sorry for this hiccup right there. It made me chuckle on the inside. All right, as always, thank you so much for watching, and I'll see you in my next video. Bye.